Recently, scientists have made an astonishing discovery in the cosmos: structures of colossal size, exceeding by more than 100 times the magnitude of our own galaxy, the Milky Way. This discovery has left experts in awe of their immensity. These structures completely challenge our understanding of the universe and fundamentally change what astronomers thought they knew until now. Trying to comprehend their magnitude is overwhelming and challenging, but before we delve deeper, why not give the video a like and leave a comment? Now, let's focus on the Boots superclusters. These superclusters are famous for their proximity to the Boots void, one of the most remarkable voids in the cosmos, discovered in 1981. Located about 700 million light-years from us, this void has a diameter of approximately 300 million light-years. Within the Boots are two superclusters, both approximately 1 billion light-years from Earth. The first is about 830 million light-years away, while the second is behind it at a similar distance. Although a comprehensive study of these superclusters has not yet been conducted, they are known to be considerably larger than the Virgo supercluster. The Boots void was discovered by Robert Kitzner, August Ulmer J., and Paul Stephen Shackman in 1981. Subsequently, several studies were conducted to better understand it. A notable absence of galaxies was observed in certain areas, leading to further investigation. Over the following years, numerous galaxies were discovered within this void, increasing the interest of the astronomical community. Although several dozen galaxies have now been discovered within the Boots void, this number is still relatively low compared to what we were expecting to be found in a region of similar size in the universe. This suggests that there are still many galaxies to be discovered within this vast cosmic void. The Saraswati supercluster, recently discovered by researchers at the University Center for Astronomy and Astrophysicists, encompasses a vast space estimated to be about 600 million light-years across. This enormous structure harbors a combined mass equivalent to more than 20 trillion suns. Its discovery is especially noteworthy because astronomers have so far identified relatively few superclusters of this magnitude, which places Saraswati among a cosmic elite. This supercluster joins a few others known for their large size, such as the Sply concentration or the Gray Sloan wall in the nearby universe. But what makes Saraswati unique is its super far-off location, approximately 4 billion light-years away from us. This is the first time we have observed such a distant cluster. Even Shapley, which is one of the largest known, is 8 to 10 times closer. The researchers located Saraswati by examining data from the Sloan Digital Sky Survey. According to their estimates, the supercluster contains at least 43 groups and clusters of galaxies, including 400 galaxies in total. Most excitingly, its extreme distance means that the light we see from the supercluster has traveled enormous distances to reach us, showing us what the universe was when it was just 10 billion years old. Another example of a massive cosmic structure is the SFA2 Gray Wall, also known as the Cosmic Wall, discovered in 1989 by Mark Greener and John Utschka. This giant filament of galaxies is remarkable for its extraordinary size, ranging in size from 50 to 750 million light-years across. With a width of 200 million light-years and a thickness of about 16 million light-years, the SFA2 Gray Wall is home to 3 equally massive superclusters of galaxies, known as Hercules, Coma, and Leo. However, there is still no conclusive evidence for the full extent of this structure due to the so-called zone of invasion. This area of the universe, blocked by gas and dust from our own Milky Way galaxy, prevents astronomers from determining whether the wall continues beyond what they can currently observe. This phenomenon, known as a zone of invasion, constitutes of about 20% of the universe, which is hidden from our view due to interference caused by stars and stellar dust in our galaxy. At optical wavelengths, astronomers find it difficult to see through the dust block of our galaxy. However, they can circumvent this limitation by observations in X-ray and infrared light. According to the standard model of the evolution of the universe, structures like the Great Wall form a long filaments of dark matter that resemble a spider web. This dark matter, invisible but detected by its gravitational effects, it is believed to detect the large-scale structure of the universe. It gravitationally attracts visible matter, thus forming the long, thin walls of galactic superclusters. The Gallium supercluster, discovered in the 1980s, spans some 910 million light-years. To put it in perspective, the supercluster of anarchy, like the Great Attractor, is about 520 million light-years across and has an enormous mass. However, the Gallium supercluster is even larger, being approximately 1.7 times more gigantic than the Anarchy supercluster. The supercluster hosts an impressive number of galaxy groups, giant galaxies and dwarf galaxies, being about 10 to the 29 times more massive than the Sun. The Pisces-Cetus supercluster complex, discovered in 1987, is another structure of great magnitude. It contains the local Virgo supercluster, where our own galaxy, the Milky Way, is located. This complex also hosts a large number of groups and clusters of galaxies, extending over 110 million light-years and with an estimated mass of 10 to the 18 solar masses. Pisces-Cetus is not the only structure containing the Virgo supercluster. The Annihilation supercluster also includes it. In short, the Pisces-Cetus complex represents one of the largest and most massive structures in the observable universe. According to Thule, who was its discoverer, the complex consists of 5 distinct parts, including the Pisces-Cetus supercluster, the Perseus-Pegasus chain containing the Perseus-Pisces supercluster, the Pegasus-Pisces chain, the Sculpture region containing the Sculpture supercluster, and the Hercules supercluster. In addition, the Lanichi supercluster, which contains our Virgo supercluster, as well as the Hydra Centaur supercluster. This set of structures was named after the richest superclusters, the Pisci edges. The Perseus-Pegasus filament is a huge filament-like structure that hosts the Perseus-Pisces supercluster. It extends approximately 1 billion light-years from Earth and is considered to be one of the largest known structures in the universe. It is located near the Pisces-Cetus supercluster complex, although some accounts attribute the discovery of this filament to Clyde W. Tumbley in 1936, during his research for trans-Saturnian planets, Walter Ever also reported parts of this cluster. The Great Boss Wall is a supercluster complex consisting of 2 main superclusters and several smaller ones. It was discovered in early 2016 using Baron Oscillation Spectroscopic Survey. Approximately 1 billion light-years across, and with a remarkable number of galaxies, some visible and some obscured, it has a total mass of about 10,000 times that of the Milky Way. Although its exact size has not yet been determined, this Great Wall is known to be extraordinarily large. Scientists mainly debate whether the supercluster complex is moving as a unit or whether it is gradually separating as the universe expands. According to Joshua, filaments play a crucial role on the large scales of the universe, forming a kind of cosmic web surrounding the voids, and these walls represent the thickest strands. Unlike other large-scale structures, Boss superclusters are much more densely populated with high stellar mass galaxies. This discovery provides astronomers with a valuable opportunity to better understand the large-scale structure of the cosmos. James Webb Space Observatory has done it again. As time goes on and it discovers more and more about our space, it is fascinating how it manages to redefine virtually everything we thought we knew about space or defy any calculations made by scientists. Recently, the James Webb has detected an object that is 100 times larger than the Milky Way. How did it manage to discover such a structure? And what does this mean for humanity? Join us to explore a little bit more about it. If you are interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. The number of structures that have been discovered occupied a wide range of characteristics. After publishing this first photograph on July 11, 2022, the fascination they generated made it clear that we are just beginning to get to know our outer space. This of course means that it would have been only a matter of time before we find an object much larger than our own galaxy. Space seems to be replete with such comparisons. After all, in our galaxy we have a planet larger than many suns, Jupiter, just as there are many moons of similar size to the Earth. Back to the topic in today's main protagonist, let's talk about the strange Alcyonian galaxy. This is a radio galaxy, a type of galaxy that is very luminous in radio frequencies. These radio frequencies span a particular broad spectrum, with wavelengths ranging from 10 MHz to 100 GHz. Although the James Webb Space Telescope has not yet studied this imposing galaxy in depth, it is hoped that it will soon shed light on the mysteries it conceals. Alcyone is located 3.5 billion light-years away from our galaxy. According to several scientists, this galaxy is one of the strangest things ever found in our universe. The beginning of its history is complicated in itself. This massive and imposing galaxy was discovered by accident in what is being catalogued as a great stroke of luck. Estimates made by scientists indicate that this galaxy would rank as the largest known galactic structure in our universe. To understand this a little better, it is necessary to note that, as a general rule, radio galaxies have a massive black hole at their center. As it traps matter in its interior, two radio jets are expelled to opposite sides of the nucleus of the galaxy itself. This process ends up generating a large amount of loose particles in space, particles that end up forming part of the creation of new stars and planets. Simply put, the galaxy is an ecosystem in itself where a constant cycle of creation and destruction is repeated and respected. At the time, Alcyone was discovered by a group of scientists using the Low Frequency Telescope Array, or LOFAR. This is an array of variable frequency telescopes spread across Europe. Although the existence of Alcyone had been suspected for some time, confirming its presence had proven to be much more challenging than expected, especially since its columns were faint. However, years of observation facilitated its discovery, as scientists reprocessed all the information they had about the galaxy, discovering new and interesting patterns that eventually formed the final pieces to find Alcyone. This methodology is relatively popular, being used on several occasions to prove or disprove the existence of other galaxies. The case of Alcyone is particularly interesting and curious, largely because of its size. This factor has generated many doubts over time, considering that there is no reliable explanation to explain how it managed to reach its size. Throughout the video, we have mentioned that this galaxy is considerably larger than the Milky Way, but how massive it really is. It is necessary to understand that galaxies, as well as planets and stars, are measured from one point of view, that of the Earth. The only way to estimate the size of a galaxy is by observing astronomical images captured by a space observatory from its point of view. Based on several reference values, it was possible to accurately measure the wingspan of Alcyone, which is located at 16 million light-years. Although this number alone seems surprising, it turns out that the size of its galaxy is equivalent to 100 times the length of the Milky Way. Here we must take a moment and weigh our knowledge especially about this particular type of galaxy. To date, there are approximately 1,000 radio galaxies known to exist, of which only 10 of them are more than 10 million years across. With its size and being located 3.5 billion years away, if this galaxy were visible to the naked eye, it would occupy the same as our moon in the celestial vault. Alcyone's discovery is of great scientific importance, providing vital information about some filaments of our cosmic web that, even today, are difficult to characterize. When talking about the cosmic web, we're basically talking about the building blocks of the universe, composed mainly of interconnected filaments and dark matter bonded with gases on which galaxies will eventually be built. The clearest and most relevant example of these filaments would be the Great Wall of Hercules boreal corona, which measures about 10 trillion light-years. hosting billions of galaxies. On the other hand, when talking about voids, it is necessary to mention the Kina, Barber, and Cowie, popularly referred as to KBC. Its diameter is estimated to be around 2 billion light years, and our galaxy is contained in this spatial region. Like the Milky Way, Alcyonius lies in its own filament. Its columns experience a kind of headwind as it moves through the medium. This subtle change affects its trajectory and the way its columns move, which seem to perform something resembling rather slow dance. About its size, much speculation has been made. Some scientists theorize that its impressive size, which seems to defy physics itself, is due to the fact that this galaxy was born from a black hole. Although this is a possibility that seemed viable, it was proven incorrect. A curiosity that would be linked to the beginning of the galaxy is that in all its extension, no moon has been found. It is important to know that moons are quite common stars throughout our universe, so the total lack of moons in an entire galaxy could imply or provide clues about its origin. Theories explain that the lack of moons is not because they do not exist, but because how difficult it has proven to be to explore this galaxy. It is expected that over the next few years or even months, the James Webb will be able to provide necessary information to clarify the mysteries hidden in this galaxy. In addition, astronomers have pointed out that this galaxy is in constant expansion. As a consequence, Alcyone is a region with a low density than the average in which it is located. Scientists who are part of the group that found Alcyone commented that beyond the geometry, Alcyone and its host are suspiciously ordinary. The total low-frequency luminosity density, stellar mass, and supermassive black hole mass are lower than, but similar to, those of the medial giant radio galaxies. Only time will dictate the fate or what we will be able to discover about its galaxy, which could hide in its imposing size some answers that will allow us to learn a little bit more about how our universe works and the cycles through each it goes through. The James Webb Space Telescope has transformed our view of the universe. The images obtained by this large infrared-capable telescope have caused a sensation around the globe and have been shared on a massive scale. It is safe to say that the James Webb is the most advanced telescope in the history of humankind. So far, the scientific observations made by the James Webb Space Telescope have been invaluable and fully justify the $10 billion invested in its construction. The first images from the telescope were released to the world on July 12, 2022, and experts believe they showed that James Webb is at its best and fully prepared to continue uncovering the secrets of the infrared universe. These images include the cosmic clefts in the Carnot Nebula, the exoplanet WSP-96b, the South Ring Nebula, Stephanie's Quintet, and the stunning deep field view of the universe, although these were only the first images. Since then, the James Webb Telescope has provided scientists with even more spectacular and stunning images of the cosmos. Some of these images have perplexed astronomers and cosmologists, and have led to the publication of many astronomical articles. However, some of these papers have generated some panic among cosmologists because they seem to directly contradict the Big Bang theory. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. To better understand what is going on, it is necessary to first understand what exactly the Big Bang theory is. The Big Bang is the predominant cosmological model that explains the evolution of the observable universe. It was developed from observations of the structure of the universe and theoretical considerations, and explains how the universe expanded from an initial state of high density and temperature. The Big Bang theory describes an increasingly concentrated universe originating from a singularity in which space and time lose their conventional meaning. Based on detailed measurements of the expansion rate of the universe, the Big Bang singularity is estimated to have occurred about 13.787, more or less 0.02 billion years ago, which is also approximately the age of the universe. Although the concept of the Big Bang may seem confusing, it is actually quite simple. The universe is continuously expanding, and the name Big Bang can be misleading, as it suggests that there was an explosion at a particular time and place with a center. However, the universe has no definite center, and the Big Bang occurred everywhere at the same time. This process occurred over time, not a specific point, and galaxies are moving away from each other without a definite center. Although we cannot directly observe the Big Bang, there is observable evidence for it. For example, the heat that was generated about 380,000 years after the Big Bang can be detected throughout the universe, which has been mapped by satellites such as the Carney Background Explorer, World Ends Microwave and Isotropy Proof and Planck. During this period, the universe was very smooth and simple, with small temperature ripples. The James Webb Space Telescope, designed to image the first object that formed as the universe began to cool after the Big Bang, has seen further than the Cosmic Background Explorer Telescope or Professor Michael Webb and Professor Blanco's story. Dr. Mather, who is the lead scientist of the James Webb Telescope project, claims that this telescope could image objects that formed hundreds of millions of years after the time period that other satellites were built to see. The small changes in temperature observed by those satellites may have been the seeds that eventually became new galaxies. Although we do not know exactly how and when the first stars and galaxies formed in the universe, the James Webb Telescope was built for the purpose of answering this question. In summary, the Big Bang theory is the primary explanation of how the universe began. This theory indicates that the universe began as a hot, dense point that inflated and stretched at initially unimaginable speeds, and then at a measurable rate. Over the past 13.8 billion years from the Big Bang to the expanding universe we see today, the Big Bang theory has been widely accepted as the most likely explanation for the origins of the universe. However, new images from the James Webb Telescope are causing some uncertainty among some scientists about the credibility of this theory. Most cosmology theorists have defended the Big Bang theory as unquestioned truth for decades. But new data from the telescope are causing some people, like Alison Paltic, an astronomer at the University of Kansas in Lawrence, to question everything they have done in this field. The extremely small, smooth, ancient, and surprisingly numerous galaxies observed are completely incompatible with the Big Bang hypothesis. In the view of some scientists, the Big Bang proposes that the universe is expanding and that galaxies and other objects in expanding space should appear larger with increasing distance. However, images from the James Webb Telescope shows us more and more smaller galaxies, even those with a luminosity and mass much greater than that of the Milky Way, suggesting that the universe is not expanding and that the redshift is proportional to the distance of galaxies. In other words, the galaxies shown by the James Webb Telescope are the same size as the galaxies near us, indicating that the universe is not expanding. The images obtained show that the galaxies have a redshift that is 2 to 3 times larger than expected according to the theory of an expanding universe, which contradicts this theory but aligns with the prediction of a non-expanding universe. Previous results based on Hubble Space Telescope images showed a redshift of up to 5, which agreed with expectations of an ordinary non-expanding space. Big Bang proponents expected to see galaxies chaotic and destroyed by collisions and mergers, but the James Webb Telescope images show smooth disks and ordered spiral shapes similar to present-day galaxies. According to Eric Lerner and Ricardo Scarpa, these findings challenge the theory of an expanding universe. The data in the Panic paper indicate that there are many more smooth spiral galaxies than expected, challenging the idea that galaxies have a common formation process. Lerner and Scarpa argue that these data completely discredit the theory of galaxy formation. Furthermore, the Big Bang theory suggests that the most distant galaxies in the James Webb Telescope images look as they did 400 to 500 million years after the origin of the universe. But some of these galaxies have stellar populations that are at least 1 billion years old. According to the Big Bang theory, nothing could have originated before, which leads to the author of Panic to believe that the existence of these galaxies is proof that the Big Bang did not occur. In a study to be published in April in Monthly Notices of the Royal Astronomical Society, the researchers analyzed in detail a cluster of nearly extinct stars of enormous antiquity called HB1. The extraordinary cluster lies about 21,500 light-years from Earth, in the central bulge of stars at the center of the Milky Way. They are true fossils that revealed what the early days of the universe were like. First generations of stars formed when the only available material was hydrogen and whose age rivals that of the universe that contains them.
And now, to the general surprise, a team of astronomers has found some of them within our galaxy. To observe it, it has been necessary to combine the power of two large telescopes, Gemini South in Chile and the Hubble Space Telescope. Thanks to the sum of their data, the researchers were able to calculate the age of the stars in the cluster, which turned out to be 12.8 billion years old, which includes them in the group of the oldest ever found in both our galaxy and in the universe in general. This cluster of stars, says Stefano Sousa, co-author of the research, is like an ancient fossil buried deep in the central bulge of our galaxy, and we have now been able to date it to a distant time when the universe was still very young. These are also some of the oldest stars we've seen anywhere else. Thank you so much for watching the video. Remember to like and subscribe. This way you will be supporting the channel. See you soon.